automated teller machine, these are absolutely the kinds of issues you need to be mindful of when dealing with any kind of currency and fractions thereof. All right, so let's transition now to this file here. This is a file called non-switch.c, just to convey the idea that it's actually not using a switch. Let me scroll down just a little bit here and see if we can't read through this program. At the very top, I'm using the CS50 library, standard I/O. So that's a hint that I'm probably using printf. I'm probably using getInt or getString, something from CS50. And now here's my main routine. And the comments kind of reveal what's going on here. So in that first line, I'm asking the user for an integer. Notice that just aesthetically, I'm not using a \n at the end of the line. This is purely a stylistic decision. I just want the cursor to blink to the right of the prompt rather than put it on a new line. But that's not strictly necessary. The next line we used last week, int n gets getInt. So that's relatively straightforward now, hopefully. In future weeks, we'll actually look inside of getInt as to how it's working. But for now, you're welcome to be blissfully content just assuming it gets an int and hands it back to you. So now we're finally using Boolean expressions in C that are actually using the AND expression here. So in short, this seems to be a simple program that says if the user inputted a number that's between 1 and 3, go ahead and tell them you picked a small number. Else, if it's between 4 and 6, you picked a medium number. Else, if you picked 7 through 10, it's a big number. And anything else, negative, 0, something huge, it's going to say you picked an invalid number. So here too, just to point out an FAQ or a common mistake, realize that when you AND two things together, you don't necessarily want to say, for instance, if n is greater than 5 and n is less than 4, do this. Because if you just think through that logically, make sure that the two ranges you're comparing are actually inclusive and not something that's greater than 5 and less than 4, which is obviously impossible. So just think about if you're ever running into a bug where you're using these Boolean expressions, just consider what your actual logic might be. So this is starting to feel a little ugly, right? I've got 4 different conditions. It's a little hard to read with all the ands and the greater than equal signs. And just to be clear, to express the notion of greater than or equal, on paper you would say angled bracket and then the line under it. There's no such key on the keyboard. So the convention is angled bracket and then an equal sign. 2 separate characters with no space. So let me improve this, debatably, with switch.c, non-switch, switch. Let me go ahead and improve this as follows. So rather than do this, I could actually say switch, and then what do you want to switch on? Well, whatever the value of n is. And now I've got some placeholder text here, and what I can start to do is say, all right, in case 1, do this. And then I'm going to steal my text from down here. You picked a small number. And then I'm actually going to do this. I need to say break. But then I can do this. Whoops, don't do that. Then I can do this. I'm going to go up to 4. We'll come back to the ones in the middle. You picked a medium number. And then I'll do one more for good measure. Case, let's see, I think it was 4, 5, 6. So 7 was the next one. You picked a big number. And then just to make sure I capture every possible scenario, I'm actually going to have at the very bottom here what's called the default case, where you picked an invalid number. And then I'm going to close the curly brace. So again, we'll fix the fact that we're skipping 2 and 3 and 5 and 6 in just a moment. But this is just another syntax to achieve exactly the same thing that doesn't have all of these angled brackets and such. Instead, the switch statement says, look at the value of n, and then check this list of possible cases. And whichever case actually applies, go ahead and do that one. And only that one. So I can actually now round this out. You can have multiple cases. I can say case 2 and case 3. Down here, I can say case 5, and I can say case 6. And then lastly, down here, I can say case 7, case 8, case 9, and I think I had 10 before. So case 10, and that's it. So arguably, this too is now starting to devolve in something a little messy, but at least it's a little more skimmable. Rather than have to parse something visually that's kind of a big jumble of text, it's pretty wide, it kind of requires more thought. What's nice about switch statements, just as a feature of the language, is that bang, 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 you can see what the applicable cases are. So just realize this is an option, but the only gotcha is that what you switch on generally has to be an int or has to be a char. There's a couple of other things you can use, so it's somewhat limited. Yeah? Exactly. Case 4 or 5 or 6 are all going to do the same thing. They're going to say you picked a medium number. But this fact, I've introduced, notice, this new keyword break, which you can actually use in loops as well. Notice what happens if I don't have that break. So I think I got my syntax right. I'm going to go ahead and save this in my terminal window down here. I'm going to go ahead and make, this is still called non-switch, even though we've changed it to a switch. Compile's OK, so that's always a good sign. Non-switch, give me an integer, let's say 5, you picked a medium number. Let's say 1, you picked a small number. Let's say monkey, retry. So that's the CS50 library catching that. 0, that's my own program catching that, saying it's an invalid number. But notice what happens if I forget this break statement, which literally does what it says. Break out of this chunk of code. If I forget this, and I forget this, whoops, not that. If I forget this, and this one, leaving out the breaks, which is easy to do, and now recompile my code and make non-switch, and then run switch and type in 1, what's happened here, right? This is absolutely a bug, but that's because, again, C, being a computer language, needs to be told exactly what to do. And what these case statements mean is the instant you match one of these cases, the code just starts executing everything you've written below it, and only once you hit type break, semicolon, does it break out of the whole switch statement. So this is both an advantage sometimes and a disadvantage. An advantage in that we can consider multiple cases, but a disadvantage if you leave out that break. Strictly, it's not necessary to have a break under default, but perhaps as a matter of good style and consistency, it's good to have it there. But it does need to be at the bottom. Yeah?
It does seem odd that it displays all of them, even though the value of n doesn't change. What about the way that switch works makes that the case?
It's a good question. So what is it about switch that makes it the case that all 4 of those outputs are printing? It's literally the definition of switch. When you match a case, start executing code until you see break. So the subsequent case statements are ignored. So the compiler is smart enough to realize, oh, I've seen case, I've seen case, I've seen case. But until it sees break, it's going to keep executing everything that I happen to have indented here. So it's just the definition of the statement. Other questions? Yeah, in back. Good question. Is there a way in a switch to consider a big range of numbers? No. You need to go back to the if condition and your use of greater than or less than if you actually want to consider a range. So you wouldn't want to use a program like this for 1 to 100 because, frankly, then the switch implementation would just be messier and uglier and much longer than the corresponding if-else approach. So again, just another tool for the toolkit, another way in which you can solve these kinds of problems. So let me go ahead now and open up one more example here. So this one is called positive1.c. And it's the first version of a little program that actually uses that feature of a loop called do while to actually prompt the user again and again and again, especially if he or she is being difficult. So there's a couple of interesting nuances here, though. So notice first that, again, the program starts in a familiar way with these 2 libraries and a bunch of comments up top. Int main void is the same as usual. But now notice a couple of new things. So 1, do, and then notice there's nothing parenthetically to the right. It's just do and then open curly brace. Because what's interesting about do while is that these lines are always going to get executed no matter what. So it's an opportunity to do something before you even check some condition. But at the bottom of the loop, you're only going to do it again if that condition checks out. So in other words, if the user here provides a number that's less than 1, I'm going to go through the do chunk of code not only the first time, but again and again and again until the user finally cooperates and gives me something that is not less than 1, like 2 or 3 or 4 or 1 itself, at which point the loop will terminate. And then it's finally just going to say, thanks for the 2, or whatever it is I typed in. So just to be clear, let me go ahead and run this at the bottom here. So this, again, is positive1. So make positive1. And I'll zoom in. Enter. Compile is OK. Positive1. I demand that you give me a positive integer. I'm going to give it -1. It's going to do it again. -2, -3, -100, 0. Still not cooperating. But if I finally give it 1, thanks for the 1. And this is a way, again, of maybe in, say, pset1 actually doing something again and again. But notice what I did. What's kind of interesting about my declaration of n here that I've not done in past examples? Yeah, I kind of declared it up top. And this was why I think we proposed this last Friday as an option, but then decided, just do it all at once because it's more elegant, right? Every example thus far, we've not had int n declared way up there. We did something like this. But this introduces a problem now. So n is clearly a number that I want to use in this program. Not only getting it inside of the loop, but I want to use it, obviously, in the printf at the very bottom of the program. But here's a gotcha of C. When you declare a variable, it only exists within the confines of the most recently opened curly braces. Those curly braces define a buzzword called scope. So int n, as declared here between those curly braces, only exists in your computer's memory while you're executing code in between those two curly braces. The moment you pop out of that loop, for instance, at the very last line, n is gone. The RAM, the memory that it was occupying, those 32 bits, have been taken away from you, reclaimed for some other random purpose in the computer, and you no longer have access to those bits. And thus, n is out of quote-unquote scope. So what you'll see if you make this mistake is the following. Let me go ahead and recompile now that I've saved this file with make +1. And already there's a whole bunch of errors. Again, this shouldn't necessarily mean you've made a whole lot of mistakes. You made one that actually has a ripple effect on the rest of your program. So what's going on? So first of all, look for the first sort of reasonably phrased line. All right, so in function main. That's apparently where my issue is. This denotes line 22 of +1.c, unused variable n. So this is the error we saw before. And it is unused now because I'm declaring n inside those curly braces, but then I'm not using it. It's like z in that silly example earlier. But there's something more here down here. Then it's saying, confusingly, on line 24, which is down here, n undeclared, first use in this function. So GCC is being consistent with this story. The moment you exit those curly braces, n is gone. So on line 24, at the bottom of the program, n no longer exists, and so the compiler recognizes as much and yells at you and doesn't even let you compile or run this program. So to just roll back, what's the fix here? What's the solution? Yeah. Quite simply, you declare n outside of the scope of that loop. And even though, frankly, it looks or might start to feel a bit ugly to kind of put this variable in no man's land up there, that is indeed the correct solution. It's still inside of main, so that means every part of main has access to it, including inside of the do loop's curly braces, but at least now it's within scope for the entire function. Now, just as a teaser, technically, and those of you with prior programming background, and especially in Java, might be in the habit of putting what are called global variables, where you declare variables outside of main even. The advantage of this, as we'll see in future examples, is then every function you write, not just main, you can write your own functions, just like you can write your own scripts in Scratch. Every function you write will have access to n, but this is generally considered very bad, very messy practice. So we'll come back to this, but for now, the correct solution is indeed to put it right inside there, outside of the loop. Yeah?